All right, here we go. We're finally ready. So, time for part 3 of our Ratrig V-Minion build. Looks like nobody's in the chat. Oh, we got 4 viewers right now, so we're ready to take off. Let's go, everybody. So, here goes nothing. All right, so for anyone who doesn't have the background here, we're building the Ratrig V-Minion. I just ate a big old meal, so I should be able to keep going until this printer is done. So right now we got to the tool head assembly part, and I had to take a little break just because this is a very time-consuming build and I can't do it all at once, but we're ready to keep on going with the tool head. So we put some bolts in here, put some nuts in both of these 3D printed parts, and now I think it's time to attach all of the fans and hot ends and stuff to this tool head and get it mounted to the printer. But while I was doing some research on this project, I found out about this EVA. I'm still not sure what EVA stands for. Let's see, EVA, like in PET very up. EVA, I mean, it'd be nice if they just told me what it means. I'm still not super clear on what EVA stands for. But, well, anyways, maybe it's in a different language and they don't want to explain it. But let's just get this thing built. So I believe we have a configuration where we want to attach this here LGX Mini or LGX Lite, I forget what it's called. And I also managed to salvage one of these nice hot ends. This is a Phaetus Rapido hot end. I originally installed this on an Artillery Hornet 3D printer, but we're going to install this along with the LGX. And as far as I know, this is a pretty common configuration that people do for this machine, so it should be pretty nice. Anyways, let's get started. So, all right, we got Herzelnurk in the chat. Awesome. Hopefully we can get a couple more people in here. Otherwise, it's just going to be me and the German Prince Herzelnurk. All right. So, anyways, I learned a little bit more about this EVA project, and we've got the Rapido specific build. So I'll see if this will work. I think that's what I have here already printed. Let's find it. We're losing parts already. Oh, here it is. I think I already have this piece printed. I think this is the Rapido compatible hot end, but maybe it isn't. It's looking a little bit different. So I'm just going to go ahead and download this part. I already downloaded it. And I'm also going to want to download the LGX Lite compatible component. So we'll just download that as well. Now I'm wondering, I have an LGX and an LGX Lite. I'm kind of wondering which one I should use on this printer. LGX Lite, obviously it's a little bit smaller and lighter, which will probably be more suitable for this machine. We've got a, we're probably going to keep a 4mm nozzle on this build, so LGX Lite seems plenty for me. So we'll print out the LGX Lite drive, and I'll open both of these up in Prusa Slicer. So let me just get to that. Prusa slicer, LGX light, and Rapido hot end. So here we are. We're in Prusa slicer. Now someone's telling me that there's a way to 3D print things directly from Prusa slicer. So like I just send it straight to my any type of printer that I have on Clipper. So my Creality Sonic Pad would be totally capable of running this thing. But I think I'm just going to print these two parts out. We'll see how long it takes. According to Ratrig, they suggest printing everything with 4 layers. So I've set that to 4 perimeters. We'll see how long this takes to print on my Ender 5S1. That's a pretty quick print. 2 hours, 22 minutes. That's fine by me. This part looks like it could use a brim just because it's got these little bits hanging off the edge. So I think I'll turn brims on for this print. Brim, we'll do a 4mm brim. Give it another slice. All right, so that's looking pretty good. Added 3 minutes to the print job, but that's a small price to pay to ensure success. And I think we're good. So let's send this over to my Ender 5S1. Let's see. I'm wondering if I should speed this print up at all, just to make sure that it gets done in time. I'll go through my printer settings. So we look at volumetric flow rate. This is my favorite visualization. Flow rate. Looks like pretty much everything is being printed at this relatively slow speed. Wow, that is very slow. I think we can turn that up quite a bit. So if I go into my filament settings, I'm guessing we have a minimum layer height thing going on here. Minimum layer time. So let's turn that down. I've got really good part cooling on this thing, so I should be able to get this going pretty fast. So slow down if print layer is below 20 seconds. Let's turn that down to maybe 5 seconds and see what we get. All right, 2 hours, 13 minutes, a little bit faster. But it looks like we've got really low speed settings for our external parameters there. I don't know if that's entirely necessary. I'm just getting this out of the way before we start assembling things because this will be running the entire time while I'm doing all these other builds. So I want to make sure it gets done right. They also recommend, I think, a 20 or 25% infill. All right, so 2 hours, 17 minutes. And I'm going to go ahead and turn up my fan settings. So on overhangs, I want these fans to power up pretty much all the way. So filament settings, cooling, fan speed and bridge, 100% sounds good. Max, I'll turn that up to 100% there. I don't know if that's going to really mess things up, but I really want these steep overhangs to turn out all right. So I think turning the speed up is completely warranted there. Let's see what other settings we've got. Speeds, 30 millimeters per second on the external parameters. I think I can go a little bit faster than that, but usually I'll consult my Bamboo Studio slicer settings. They've got a really good tuned profile set up in here. So if I look at their PETG settings, they've got things running at, they don't change the speed based on the filament. So yeah, their outer walls are 60. I think I can do 40, and inner walls, I can turn up the speed quite a bit. So let's turn that up on the Ender 3. We'll do our internal perimeters at 100 and external perimeter is at 40. And everything else can go up to 100 as well. Maybe keep this one a little slow. Support material. I'm not using support, so it doesn't really matter. Alright, let's give that a try and see what kind of speeds we get now. Alright, under 2 hours, that's pretty good. 2 parts for under 2 hours. I can agree with that. So let's get those printed out. Export G-code. Stream print. And I just set up a I just set something up here, so let's see. Alright, file list. We'll just drag and drop this into our file list and we'll get it started. And I don't want you to miss out on all the fun of watching this printer operate, so we're just going to hit print. And let's see, do we have our webcam working? Ah yes, there's the webcam. Sweet. I didn't preview this, so I'll get you a little OBS close-up here, or I can just full screen it like this. And yeah, that's pretty good. It's a pretty low quality webcam feed, so we'll just check in on this thing periodically just to make sure it's printing okay. But there is our printer working remotely. The beauty of Clipper and network-enabled printing. Okay, so back to our printer. Now we're exactly where we were when we left off. I've got this Raspberry Pi that I scavenged from my other printer as well. So I'm not sure how to set the screen up here. It'd be pretty nice to get this touch screen working and giving me some kind of interface for Clipper, but I'm not sure how to set all that up. We'll do the firmware in another episode probably. I think I've got enough on my plate just with this mechanical build. So without any further delays, let's get started with the build. Alright, back to our instruction sheet. So, here we are. Alright, I think I grabbed all of these parts in the last stream, and they're mostly sitting down over here. That's all fine. We'll get those put together. Yep, pretty much all of them are still here from when I counted them out earlier. Alright, I'm going to check in with the chat. Looks like we got a couple comments, some viewers streaming in. So, hello, Let Me Look TV. Hey, Samuel Williams, the founding father. Florida Man is here too. Alright, I'm not sure which Florida Man you're referring to, but good to see ya. The legendary Florida Man. Any thoughts on the Prusa MK4? Yeah, I've talked about it in a couple other streams. Basically, I think it's Prusa basically getting up to the level that they need to be competitive in today's market. Some people are saying Prusa's overrated, not bad, but not the best bang for buck. Yeah, I would say all of that is true to some extent. Did that print really start? The bed moved down a lot after homing. You see the size of the extruder gear? That is next level thinking. Yeah, this one, it's got a big ol', well, this is just a drive gear. We've got a gear reduction built into this little thing. And then these drive gears for the extruder are pretty huge too. You can see them poking out on either side here. So, LGX, big old gear extruder. Krill, thanks for the good luck wishes. And I think we're ready to start putting some stuff together. Now, if my webcam feed drops out, please forgive me. I'm using like a secondary camera that's got its own battery. I need to buy another battery for this thing, but this is where we're at this point in time. So it was hovering around 9%. I meant to charge it while I was away, but that didn't happen. So if it cuts out, then we're going to switch over to my crappy laptop webcam for a little while the battery tops up, and then we'll switch back to it. So in the meantime, I think we're ready to go. Let's do these instructions. So in the last stream we had just finished up this step. I had to do a bunch of cleanup to insert this belt here, but it's in place now. We got our little nuts attached in up there, and we're ready to move to the next step. So, looks like we've got to put some more nuts in here, so that's nice and easy. 1, 2, 3, 4. All right. I found the best way to do this is just to hammer them into place. Herzlnerk was saying that everything looked underexposed, so I turned the exposure up just a little bit for you all. Okay, right here, just hammer these into place. Come on. I'm going to give you a close-up view here. There we go. Okay, so I'm going to get this. This one's kind of in a corner here, so it's a little bit harder to hammer it. So I'm going to open these up one step. Handy Knipex pliers. Two down, 2 to go. The next 2 get put into these kind of strange corner holes here. Didn't even see those holes earlier, but we got to use them. All right, and I'll use this Allen wrench to hammer these. And if anyone thinks my choice of tools is odd, don't worry, I'm not doing this for the camera. This is actually how I build things. So it works. Just gotta trust me on that one. All right, and I'm actually gonna try something here. I think I'm gonna turn off my my camera's rear display to see if it'll charge a little bit better and save up its battery power. So I think everything's still working. Yeah, we're still good here. I think it's all good. So we're just gonna keep going, and hopefully the webcam feed didn't cut out. All right, good luck with the build. Have you seen Chronic Mechatronic? He's making a printer out of wood. Not just the printer guy, but electronics, so he has some unique approaches, mostly due to finances. Well, it sounds like he could use a little more money. I mean, building a printer out of wood isn't the optimal choice, but I respect his decision. And it'll be really low cost. If you make a really beefy wood structure, that's going to be stronger than something made out of steel anyways, if it's just a thin steel housing. So, I mean, I think a wood printer could be a pretty decent idea. Also, it should have great vibration dampening characteristics. So, yeah, it could be less susceptible to ringing and stuff. All right, so that step's done. All right, Herzlnerk gave an answer for what EVA stands for, but I don't think it was a genuine response. So we're not even gonna validate that with a response there. Sorry, Herzlnerk. So let's see. We got this little fin thing that gets attached up here. So. So the downside of this lack of a viewfinder means that I have to use... Oh, wow, everything's all blurry. Okay. Ooh, the camera didn't know what to focus on there. It was just looking at a sea of white. Okay, now I've got a little preview of what's going on using my my OBS. So, all right. I think this is the right one. Let's see. Yeah, that looks like about the right length. We'll pop that one in next. So this is a pretty cool situation with the standoffs here. They're basically running the entire length of the part, so they're adding a bunch of reinforcement. It's just like having a steel reinforced 3D printed part. Pretty clever there. The downside is this one isn't wanting to get popped into position as easily. But it'll go if you just convince it. Oh, and someone was asking about that print to see if it actually started. So let me go back to my, well, let me get this last screw in, and then we'll go back to the 3D printer cam just to see if that Ender 5S one actually started the print job, or if they're just being a slacker down there. Now I think this would have been a really slick looking build if I used more of this shiny chrome steel, because chrome steel on white just looks really classy. But, you know, I wasn't really planning this out too much, and we've got a strong black theme on this printer anyways, so having a couple black fasteners here and there isn't going to be that big of a deal. Alright, we'll tighten this down. So having 3 metal supports in here is going to make this a really strong part. So that's something you always want to look out for when you're designing 3D printed parts. If you can do some clever stuff to make it stronger, that's always going to benefit you. So this is really tough and sturdy right here, thanks to these 3 screws running through the length of this part. Alright, let me pull up my webcam feed to see if old Ender 5 is getting the job done, and oof, that's actually not looking so great right now. Ooh, I don't know if this print is working all right, but I might need to run down there and intervene if it's doing too bad. Well, that would be wise to do, but we're just gonna, you know, this is gonna be fine probably. What do you think? Should I run down and check on it? I mean, it hasn't failed to print so far, but who knows? Maybe something got popped out of calibration there. But as you can see, we're done with this step. Now I'm going to move on to this step, attaching the fan. That's pretty easy. I think I can figure that one out. So I might as well get this stuff ready. Well, we actually don't have these parts yet because they're printing. So that's going to be a little bit of an issue. Yeah, I think I'll definitely want to wait for my Rapido to get my Rapido mount to finish up so I can use this guy. And then looks like I need to attach this little part to the side. Right here. But yeah, that's going to have to wait. Also, I have some preparations I need to do with this LGX. Apparently there's a bunch of square nuts that I need to insert into this thing, which I'm not sure if I have. We'll see if there's a couple in the spare pile. But it looks like they only gave me 1 square nut, and that might be for something specific. So let's look around for that. Yeah, I'm definitely going to have to look around for some square nuts too. I have an LGX, I have a regular LGX that has square nuts built into the sides. So I can scavenge that to get a couple of square nuts to put into this thing. But we'll figure that out a little bit later. Then the X-axis end stop, I don't think we're going to use that. I'm going to set up sensorless homing. Yeah, and this is the step where it's like adding 3 square nuts to the Bondtech LGX. It seems like they should provide those for you if that's kind of the standard build, but they didn't. I'm guessing Bondtech might have supplied these square nuts in the kit originally, but I lost those, so that's not going to do me any good. Alright, so LGX Lite printed part. I guess I already have one of those. If it's part of the default build. Let's see what we get. Alright, what does it look like? It's like this face looking thing. I mean, the only thing that's somewhat like that is maybe this, but let's see if that is what we're working on in Prusa Slicer. I think it's this thing right here. Yeah, that must be it. Looks like it's been pretty heavily revised here. Hopefully that ends up working out when I print it. But these holes, oof, this doesn't look like it's the right part. Let's see. Let's try and figure this out. So, looks like it goes on this way. I'm having trouble understanding this. Oh man. This is like way too many parts. Can't I just print out like a one-piece thing? That'd be much more convenient for me. Oh my. Oh my, oh my. This is looking like a lot of little pieces here. Well, if it's like anything else on this machine, it's gonna seem really well built by the time I'm done with it, but just seeing all these individual pieces, I'm not a huge fan of it. Man. Alright, well, let's see how far we can get. Yeah, I don't think I printed out that part originally, so we're definitely going to be missing something here. So in this case, I think I'm just going to pop back to this step, and we're gonna look at our electronics enclosure. We're actually not building this electronics enclosure. I've got something else cooked up for us. I have a community-built electronics enclosure. So let's work on this for the time being. I'm guessing it'll probably take a while to put together, so that'll give us plenty of time for our prints to finish up. So if we look over here, move this all the way up. This isn't fast at all. But here's all of our components. It's looking pretty good. I'm gonna zoom out a little bit. There we go. So here's all of our components. I guess it's designed for some pretty standard hardware. I'm hoping that my SKR will fit in here. If we look at the hole pattern, ooh, that looks like it matches up just right. Heck yes. Alright, so that's one part that's going to fit just right. And the next part will be this Raspberry Pi. I think I'm just going to pop this screen off, and we don't need this screen. 3D printers don't need screens. I don't know why everyone's so concerned about making sure every 3D printer has a screen. I'd rather have the printer be fast than make sure that everything has screens. So let's take it down here and we'll pop this Raspberry Pi off. I just need to find a screwdriver. Alright, and how's the chat going? You're printing it right now? Yep. Should be 4 holes for the rail and the cut for the stepper. EVA has a 4-part cage and this is just the top part one. How fast are you printing using the Ender 5S1? Mind sharing the configuration to your Patreon folks? Yeah, I told you guys I was going to work on it. It's probably not going to be out for a little while. But right now, I just bumped up the speeds pretty much arbitrarily. I'll let you take a look at my settings just a little bit. So this isn't really a high-speed profile. PETG, you're pretty limited in how fast you can print, no matter what. So yeah, it's just not going to be super fast. If we look back to our print, looks like everything's going down all right. I mean, this is a really low quality webcam, so can't really tell what's going on there. But I'm just trusting that it's working. I trust my Ender 5S1. Now that trust is probably misplaced, but that's besides the point. Okay, so yeah, here we go. I just need to unscrew these 4 screws here. I'm gonna pull up our OBS and focus. Let's do this. Alright, and I might need to get some electronics standoffs for this case, just so that the PCBs aren't sitting flat against the plastic parts. That'll help, so if I have a fire or if I wire things up horribly and it starts to overheat, it'll be like separated off from the plastic case and it won't melt it and potentially light it on fire. So that's going to be a good thing. Alright, so this Raspberry Pi screen will live to see another day. It's going back into the pile of unused electronics parts. And here we go. We've got a Raspberry Pi Model 3B. What are these worth? Like $5,000 nowadays? Pretty sweet tech here. So yeah, this one, if I'm understanding this correctly, it gets attached right up here. So we've got our Raspberry Pi kind of stuck on this top plate, and then our SKR stuck on the bottom plate. And we got our SKR stuck on this bottom plate. So it should be pretty sweet once we get it all finished up. I'm not sure if there's any documentation for putting this thing together, but well, we'll just see how it goes. And the hardware kits that I have don't include anything for putting this together because this is like an aftermarket kind of thing. So let's see. I'm going to go run and grab some M3 brass standoffs. So while I'm getting those, why don't you just watch this printer do its thing. I'm going to run downstairs and I'm going to be getting some parts and we'll check on this. I'll kind of square up that camera angle too while we're at it. So be right back. Alright, how's that camera angle? I think that's looking a lot better on that little stream. Ooh. But I got some parts here, so we'll be able to proceed with the build. Proceed. Let me go over the comments real quick. Make sure we didn't just have everyone abandon the chat all at once while I was running down to the local hardware store, aka my basement. So here we go. And now for the chat. Alright. Didn't he just recently release an Ender S5? Yeah, I released one Ender 5S1 profile, but I want to release a pack with a bunch of different profiles. It's just one of those things that's going to take some time. Mostly, I'm just going to go into this Bamboo Lab studio setup and just copy a majority of these settings, but turn them down just a little bit, applying some common sense with what I know about the Ender 5S1. So that's basically going to be my approach, but yeah, it's something that's going to take a few hours of just sitting there doing some pretty boring work. So yeah, that's just something I got to get around to. So back to the chat. How fast are you printing? You'll end up liking the EVA. It's very easy to work on later on if needed. That's awesome. I really want something that's easy to work on. Plus, I like how, based on the drawings that I was looking at, it looks like it's just like a box that's completely surrounding this extrusion. So anytime you get boxes in engineering, you know you're into something good. So at the same time, lack of assembly kind of left me in the dark when it came to tune up my printer. I don't know what was what, so I appreciate the build and would get to know it a little bit. It's okay, but I want to see a nozzle cam at 5,000 FPS. That's some fast speeds. Yeah, a nozzle cam at 5,000 FPS would be pretty insane. Not sure why you would want that, but I guess you could see some pretty cool stuff, like some viscous forces, and get a lot of insights about what's going on with your 3D printing process. But as I always say, it's time to get on with the build. So I've got some brass hardware here. These are my M3 spacers, so I'm just going to attach a couple of these into the bottom of this this plate here. And I got to use some really short fasteners too. So we'll see what kind of fasteners I have. I think I need, well, here's the tricky thing. The Raspberry Pi decided they wanted to use 2.5 millimeter fasteners instead of 3 millimeter fasteners. So it's pretty annoying to find the right screws for these things, but I think I've got some stuff on hand. This one I think is M2, so we'll see what's going on. Alright, yeah, I have M2.5 hardware here, so I think I'll be able to put something together. So let's open this up and see what we've got. So these are my shortest bolts. I think I'm going to use these. 4 of them, just sticking through the bottom of this plate, will be used to attach this SKR onto this little enclosure. So if let's see, I think I kind of got to force these through. I'll just take all 4 of them and poke them through at the same time. One, two, three, 4. And this part was printed on my Ender 5S1 if you're curious about the print quality that I've been getting on this thing. It's pretty good. Nothing bad about it. Most of the other parts were printed on the Bamboo Lab, so I'll give you a close-up of those. Here's the Bamboo Lab. It's kind of hard to see what's going on here. Yeah, the stream quality is like nowhere near good enough to actually show what's going on with these parts, but I figured I'd try. Alright, so... Alright, you're saying the... and show how unevenly it dumps buckets of plastic, but it looks great from our perspective. Putting down to atom resolution and quality. I don't think... I think I'm actually spending some time just chatting, which is slowing me down. But it is a time-consuming build. I think altogether, if I were just focusing on building this as fast as possible, and I didn't run into any issues with missing parts or whatever, you know, me just not knowing how this build works, I think I could probably get it done in maybe 6 to 8 hours, but that would just be a miserable time. Like, you'd be working real hard to get that going that fast. Oh my. Okay. Placating the masses, yes. Is that a good word for it? All right, there we go. That's one end. I certainly don't want to spend more time than I have to build this thing. So I'm not intentionally drawing this out. Part 3 in the same day as part 2. You're smashing out this build. Yeah, I figured I didn't want to just leave the stream going while I went out to eat, so that's why we had a little break. But I do want to get this thing done as quickly as possible so I can get back to my other builds and filming and editing YouTube videos. Alright, so I'm just going to grab these and really tighten. Oh crap. I think I stripped one of these spacers already, so I gotta be careful with this. Alright, how do we be smart about this? I know how to be smart. Use fire. So I'm hoping that'll soften the plastic up enough so that I can kind of clamp down just a little bit more here. Ideally, you want like at least 2 threads of engagement whenever you're dealing with any type of fastener. So if I just spin this one a bunch, it's going to build up some friction and heat up that area. And hopefully that'll get it to sink in a little bit more. Maybe I'm delusional. Maybe I'm delusional about the amount of heat I can generate by spinning this around. I think I can melt it. Alright, so that's nice and sturdy. So I'm going to go ahead and do that for all of these. Just make sure we don't have issues later on. If these screws pop out and then my main board comes loose, that's going to be a real bad time. So I'll just hit these with a little more fire. This would be better if I had a power drill or something, so I didn't have to spin this by hand to heat it up, but I think it's going to be all right. Okay, that's all good. Next up. So really, I'm only buying myself about one extra thread of engagement when I do this, but it's definitely worth it. So one funny bit about having lightweight components on these 3D printers is the rotor inertia actually presents a pretty large amount of the system weight. So when you use large stepper motors, you're actually adding a lot of weight to the system if we've got a heavy rotor. There's probably special stepper motors that have a lightweight rotor. For all I know, that's probably something that's already out there. But it's just another thing to keep in mind. Alright, now that's in. Last one, I think, is this one. So we'll hit that with the heat. And drive it in a little bit further. Alright, and that one just went in pretty deep straight away. So that's all good. Now I've got these little brass little threads that I can attach my SKR Mini onto. So I'm not sure which direction this is supposed to go. I'm guessing it attaches to the frame just like this. So kind of like if we look over to the printer, just like this, behind this back corner of the printer. And I think these two holes and these two holes bolt into the existing kind of T-slot that we've got there. So that's the nice thing about Ratrig building this out of T-slot extrusion, is it's really easy for people to go in there and make their own third-party mods. So in that sense, this is a highly moddable machine. So let's go ahead and put some screws on here and get this locked into place. I'm going to use these same M3 by 6mm screws, so just use those to attach right there. Alright, so let's see if this will thread down all the way. Yep, that's pretty nice. Perfection. Now I didn't fit test any of these components, so I'm pretty happy that they're all fitting together just fine. Okay. Can I, do you think it'd be worth turning the stream quality up on this? I'm sure my camera is outputting a high enough quality. I'm going into my settings just to see if I can do anything here. Choose a broadcast type. Yeah, I'm not sure. So how's the stream looking? I don't really know much about streaming so far. My webcam is outputting 1080p, 60 frames per second, so should be decent quality. I could turn it up to 40. I could turn it up to 4K, 15 frames per second, but I'm not sure if that would be a better viewing experience. And I actually have an Elgato cam link that can do 4K 30. So, I mean, I've got some options here. Oh, okay, it looks great. Yeah, then it's probably coming through at 1080p then, which is good enough for all intents and purposes. All right, that's all good. So we've got that attached. Then I've got this top piece. I assume it goes on like this. And I think the Raspberry Pi goes on the inside, which is going to be pretty wild. So this Raspberry Pi fits in here. Oof, that looks like a pretty tight fit, but it should work. It's doable. Okay, so I'm going to get some of those standoffs onto this piece here. Should go like that. Hopefully that works. I think it'll be fine. So let's just go with it. So same as before, we're going to put some of those 3mm standoffs in place. All right, and I might have to drill out these holes to make them fit my my M3 bolts. Let's see if they'll fit. Yeah, they just barely will fit through there. If I force screw these in, then I think we'll get it to work. Good old Raspberry Pi Foundation deciding to go with a completely ridiculous screw size. Yeah, actually I've got M2.5 hardware, so I'm just going to try that out. So I probably bought all of this back when I was thinking about Raspberry Pis. So I've got M2.5s, M2.5 by 6, that's what I used on the other ones, so these should work just fine. Now let me mark this so I don't mess it up. I want the Pi to go right here. And let's check on our prints. Looks like they're going pretty good here. Check it out in OBS. Oh no, we got the infinite loop going on. That's not good. Let's make that go away. All right. Okay, I'm just looking for a Sharpie. All right. Alright, so I put some very faint pink Sharpie on here just so I can remember which side is which. And let's get our unfortunately sized M2.5 hardware out. So I'll just push these through. And I think this was actually designed for that M2.5 hardware because this seems to be a nice tight fit. If it was designed for M3, it would have just slotted right in there. So here goes. I've been using Torx bits for a lot of this stuff, but Torx bits really don't cut it when you're dealing with really small fasteners like this. It just tends to strip them, or it tends to ruin the Torx bit. So I'm actually going to have to use one of these itty bitty Allen wrenches for this job. Let's see if I can zoom you in any closer. We're over, oh, where'd we go? Right there. And that's as close as we can get, practically speaking. Alright, there we go. And that's just barely sticking through the other side. We'll do the same thing for all 4 of these screws. Alright. Alright, just having fun threading steel bolts into plastic, you know. Alright, 1080p is good enough? Yeah, I think so. If I can do 4K though, I mean, I'm going to brag about my production quality and about how I'm using grow lights to light this whole streaming operation. Thanks to Vivor for sending over a 150 watt grow light for me to use. It's actually really handy for filming. It makes pretty much no noise. I can't hear it at all right now. It's spitting out 150 watts of LED light. That's pretty crazy. That's like 600 watts equivalent of normal incandescent light. Alright, got one more to go. Are you an AVE fan by chance? Yeah, I like AVE. He's pretty offensive, so sometimes I'm like, God damn it, this guy's just ridiculous. But he's got some good content overall. I always appreciate it when someone is rough around the edges, but they have a lot of technical skill. Because honestly, if you know what you're talking about, I'm glad you have a platform and you're sharing that knowledge with other people. He's kind of got the typical machinist mindset and filthy machinist mouth, where he's always saying things that are like on the borderline of inappropriate. But it's got some good content. Smart guy. I actually really like this old Tony. This he does like CNC videos and lathe videos. Does a lot of machining and stuff. And he's just a pleasant dude. Seems to know what he's talking about. Alright, so it turns out I don't have the correct... I don't have the right M3, M2.5 hardware for my spacers. I think I have some downstairs somewhere. But instead of having you sit and wait through another adventure of me digging through my random tools and stuff. I think I'm going to do this just using washers as spacers. This is how I usually do things. So I'll just get a stack of like 4 washers and use those as spacers underneath the Raspberry Pi. Unfortunately, that means I'm going to have to unscrew all of these screws that I just put in, but it'll do. Didn't take that long. Yeah, I mean, the Raspberry Pi Foundation makes some pretty good stuff. I'm not sure how they do quality control, like who all makes these things. I think it's like the only ones that can be called Raspberry Pi are from the Raspberry Pi people or something, which is why there's such a huge supply shortage. Oh, Julian, jam. Oh, all my parts are for sale. 50 by 50 by 150 millimeter so many machines could do it. Back when the machine's finished. Yep. Oh yeah, well, it's not really an issue with the hardware, it's more of an issue with this cheap Torx bit. It just came with this screwdriver. The screwdriver was like $7, so you can't really expect the finest equipment at that price. But yeah, I'll be doing a full review on this thing by the time I finish it, which should be in about 5 years. So let's see, I want to use a stack up consisting of I think these M2.5 by 10 screws are going to do the trick for me. They're quite small, but my stack up will look like this. I'll have the Raspberry Pi. Let's see how many washers it takes to be taller than that SD card slot here. Oof. I really don't like using these as spacers, but this is what we're doing. Looks like I need 5, maybe more. Maybe more like 7 washers. Yeah, a stack of 7 washers will do the trick. So I'm actually going to bump these up to M2.5 by 12s so that I'll have enough thread hanging out the back side of this panel to put a proper bolt on there. Because the last thing I need is this thing coming loose and spilling 7 little washers on the inside of my enclosure and just absolutely destroying everything. So we're doing this with M2.5 by 12s, and we're using 5 washers. I mean 7 washers. It would be nice if the spacers were built into this plate, like they had little standoffs, a little mound of plastic built up. That'd be super nice. But unfortunately, the designers of this little plate did not take that into account, so we're just having to use a stack of washers here. Man, this is going to be tricky. So I would like to use it like this with the all these USB ports up close next to this edge, and that way, let's see, where are all the other parts? And that way, I guess, yeah, I think I'll put it on this way. And I'm gonna do some cutouts here to get some USB ports sticking out the back of the machine. So I'm gonna be doing mine a little different. Hopefully this doesn't come back to bite me later, but yeah. All right, so just like that, it's looking pretty good. I'm gonna put the last 3 screws in. One, two, three, 4, 5, 6, 7. We're gonna do the same thing on all of these. Oh man, this is rough. I'm gonna try and do this kind of sideways, just so that everything stays somewhat together, because I'm going to need to put all 7 of these washers on. On all 3 of these things. Man, oh no, I'm losing them. Oh no. This is going to be tough. Now if I was smarter, I would find a way to make a little bit of G-code that just printed on the top of this existing part. That'd be pretty sweet. Or I'd just use the automatic bed level to just lay down plastic directly on this little plate. There's ways to do it, but I do not have the patience to do that just yet. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So 5 and 6. So we need to add 1 there to get to 7. We need to add 2 here to get to 7. And then we got 1 more. And we got to put 7 on this one as well. So here goes. 1, 2, 3, 4, 5, 6, 7. All right, and this is where it comes in handy to have some experience, like playing a guitar, because I'm holding these bolts in each with 1 different finger, so it's like holding a chord on an instrument. So now I've just got to spin this around without dropping any of these fasteners. Let's take some bets. What do you bet I can do this first try? I believe in my... Oh, you need 8 or 10? Well, that's just not going to happen. We're way too far down this road to turn back now. Okay, here we go. Holy cow. Oh, almost lost one there. We can do it. Oh shoot. Yeah. Okay. All right, there we go. All right. All right, playing with stacks of washers. This would be a great board game. Uh-oh. We had one washer fall out. I think it was from this last one. If it's just one, that's not too difficult to put back into place. We've got everything aligned. Oh no! Oh no! No! Okay, well, I don't think, I don't know. I don't know what I was thinking there. Alright, so we had a total failure of one of the washer stacks. The integrity of the other two is mostly intact. One of them has all 8, one of them's missing one. And technically you only need 3 of these to have it work. So I'm tempted to just go ahead and use 2, but just to go ahead and use 3, but we got to do this the right way. So that means making sure there's 7 washers under each one of these screws. Oh no. I just lost a couple more there, so here's what I'll do. I'll stick this. I've got 1, 2, 3, 4, 5. I need 2 additional on this one. One. Two. All right, and that will go back in place. Yeah, nylon standoffs would be great. The problem is I don't have every single size of nylon standoff known to man in my workshop. I mean, M2.5, who honestly has M2.5 hardware just sitting around? That's kind of silly. I mean, that's the kind of stuff you'd expect out of the imperial system, not the metric system. Anyways, now I just have to reassemble this last stack. Shouldn't be too challenging, but I just want to make sure all 4 are in there. All right. So to get this to go as easily as possible, I'm going to jam this wrench in place. Needs automatic PCB leveling. That would be nice. Okay, so it's not too bad. Things could be worse. Stacking washers one at a time. 1, 2. 3, 4. Oh, jeez. There's like 10 washers on the floor now. 6, 7. But yeah, I think the best solution here would be to build some spacers into the 3D model. Because you know exactly where those holes are going to be. So just build... Alright, I warned you. Unfortunately, the webcam, the big camera shut down because of insufficient battery power. So we're going to plug that in so it can get charged. Let me know if you guys can hear me on the new setup. Right now you're looking at the glorious stream coming from my MacBook Pro laptop. Everybody loves a good MacBook, right? We don't have any PC fans in here, do we? Alright, so I'm just going to set this aside so it can charge up a little bit. And we'll be back to lovely, high quality 1080p, whatever, later on. But right now that camera's got to charge up. This isn't too bad though. I mean, the MacBook Pro's got a decent webcam on it, so you'll be able to see what's going on just fine. Okay, and pop goes the battery, yep. Herzelnerk was waiting for it to happen. So, fortunately we got all this done. Now I'm just going to put some, put a washer on the backside just to make sure that this doesn't come loose as this Raspberry Pi heats up. Alright, so I think these are the right size nuts here. We'll just back these up with some nuts. Oh, jeez. We'll just back these up with some nuts just to make sure we don't have any melty stuff going on and the threads coming loose. Generally speaking, you don't want to rely on plastic threads when you're at elevated temperatures. Same with aluminum threads. You don't want to rely on aluminum threads at elevated temperatures, like on your heater blocks. If you have an aluminum heater block and you're heating it up past 300 Celsius, the aluminum has a serious drop-off in tensile strength, so it becomes soft like butter, and the threads come loose very easily. So if you're ever wondering why these hot ends are advertised as being copper and like high temperature hot end because it's copper, well, that's one of the reasons why. So let's tighten this up. All right, and then we've got this piece that goes on the side. I mean, this is going to be like, once I wire all this up and then try and close this book here, oh, that's going to be painful. I don't even know if that's going to be possible here. Let's see how much space we've got. So the way that this works is we've got this, this piece here, and I think it's just, we have a bolt that passes all the way through. guessing we need some longer M3 hardware to just go all the way through here, and then we'll have this much clearance inside of there. That should be fine. It's not going to be a spacious accommodation, but it should get the job done. Oof. And the nice thing is that the Raspberry Pi really doesn't have that many connections to this MCU. All it really needs is one USB port to plug into it. So it's not going to be that big of a deal that it's a tight fit. We'll just get that USB port, plug it into where it needs to go, and then pop this on top. Now, the main fun in setting all of this up is going to be where I attach all of the wires from this thing to everything else on the printer. So we're going to have to build up a wiring harness and all that fun stuff, if you can call it fun. I'm not sure if you can and be genuine about it, but I guess some people might find it fun. So I'm going to flip this around, and we're going to jump right ahead to the instructions that have to do with electrical wiring. I think I'm actually going to get this bolted into place down here just so that I have a nice idea of where everything needs to go. So to make that happen, I need some T-nuts. Let's look in our extra hardware bag. So extra parts, fasteners, and nuts. I think I'll use some of these drop-in T-nuts. Looks like we're gonna need 4 of them, so let's see, 1, 2, 3, 4. And those are M6, so I'll try and find some M6 bolts. Pretty sure I have some laying around. And looks like we have some in this bag too, so maybe it's got all the stuff that we need here. So we got 4 of these big M6 fasteners. Looks good to me. Alright, and then this gets attached just like so on the bottom here. So that's pretty neat. Looks pretty good to me. So big thanks to Big Tree Tech for supplying this board. This is their SKR3, I think. SKR2. So pretty sweet little board. Looks like it should get the job done for this build. It features 5 stepper drivers. We're only going to be using 4 of them for this build, but maybe we can set up a multi-material unit. That'd be hilarious to have a tiny little multi-material printer here. So we'll see what we can do with that extra stepper motor driver. And then this goes in just right here like this. All right, and time to get out my my M6 hex driver. All right, we'll check in with the chat, see if we've got any more questions here. If not, we'll just keep on building. All right, floor nuts. Of course, we've got floor nuts better. Aluminum infused better, possibly. PC Master Race for life, yo. JK, I'm not a PC Race word anymore. All computers are welcome. Remember, Mac was just an overpriced PC hardware, which was my complaint. Now it's actually innovative hardware with the M1 chip. They're not the only ones making ARM chips. Yeah, I think that's really cool that MacBook was able to completely change their whole perception by moving away from basically just being a PC running different hardware to being their own thing. So, like I said, I have a MacBook Pro. I use it for video editing. It's got the M1 chip, so I mean it's a couple generations out of date at this point, but it sure gets the job done when it comes to video editing. My old PC was doing such a bad job at editing videos, it'd take me like 20 hours to make one of my videos. Now I can edit in about maybe 8 hours. I can crank out a 10 to 20 minute long video in 8 hours, which is pretty good. Alright, so this is in place now. I mean, that's what's really enabled me to produce so much more content nowadays. When I first started this channel out, I would make like a video a month maybe. Now I can do a video a week. And if I was full-time, then I could probably do 2 videos a week. So if anyone wants to see me go full-time and crank out 2 videos a week, let me know in the chat, and I'll make it happen. Alright, so we've got our SKR here. I think I'm ready to get over to the wiring instructions. I'll share my screen. Now I can't point the camera at the screen anymore, so I'm going to have to switch the camera feed over to my screenshot. Display capture, I guess. Display capture. Okay. Alright, you guys seeing this now? I think you can. Here's the print. It's progressing quite gloriously, as you can see. You've got that lovely shaky camera thing going on. Feels like a Michael Bay movie. We're shaking the camera all over the place. But yeah, Ender 5S1, not a bad printer. Alright, and back to the main content, which is building this darn 3D printer. I'm going to pull up the instructions for the electronics and putting all that together. Wiring and firmware. Okay, wiring diagram. Oof. Alright, I'm going to print this out so that I can just hold the paper up to the camera, and also I don't have to keep it on my screen all the time. So let me make sure my printer's plugged in. And if anyone doesn't remember from the first stream, I have an Epson EcoTank 2D printer. Pretty advanced machine. It's got like 10K accelerations. It's set up to do multicolor printing right out of the box, so it's a pretty advanced machine. Let's give it a print. Alright, so that's awesome. This is, they designed this thing to be powered by the Raspberry Pi and SKR2. So I've got pretty much the exact configuration that this machine was designed for, which hopefully will make this these instructions a little easier to follow. So here you can see, there's our SKR2. So that's awesome that Big Tree Tech happened to send me this board. It's going to be the perfect companion for this printer. And then there's our Raspberry Pi. Those are pretty common across the board, so that'll work too. Here's one of the options. This is the Big Tree Tech Octopus. I'm just going to basically throw this page away. Don't need it. I'll be following this one, which is telling me how to wire this up to the Big Tree Tech SKR2. So, let's get a close-up on these wires. Now, one thing I really like about this board is we've got replaceable stepper drivers. So if you fry a stepper driver, you can just pop it out and replace it with a new one. And you don't have to lose any sleep over it. All right, so 2209, 2209. All of these are TMC 2209s. I'm not sure exactly how I'm supposed to wire these up. I think there's a way that you like change the jumpers around to do UART. Not exactly sure what the deal is there. But let's just go ahead and populate 4 of these slots with our little Big Tree Tech stuff. So I'll put these heat sinks on later. They're really easy to knock around, and basically you can knock it off of the board and then you just got to stick it back on, and it's just kind of annoying. So I'm going to leave everything detached for now. If anyone can advise me on the how to set up UART, that would be amazing, because I don't know much about that. So extruder 0. Here's our Z axis. Here's our Y axis. And here is our X axis. No, wait. Yep. Yeah, I think that's X. Okay, so that's good. I'm going to check the chat to see if anyone's advised me on setting up UART. I think you need to turn on UART in order to activate automatic bed leveling. And oh crap, you guys are... Whoa. Holy cow. Is the stream that far back in time? I don't know. I'm looking at something else. Okay. Holy cow, that stream looks really delayed. Okay. For some reason I was previewing like the past, but I just dragged the stream back so it's real time. Anyways, so let's see. Very nice plastic and metal integration. Yep, definitely. Weaving copper braid wire for the harnesses is my idea of relaxation. Yeah, that sounds awful, especially if one wire gets fried and you need to replace it. Terrible. I suck at making videos. Fuzzy G182. Is that supposed to be... Are you referring to me, or are you talking about yourself there? Because I think we both suck at making videos to some degree. Print supervisor webcam life, yo. All right, we'll show the print webcam just for a second here. I know you're all very curious to see what's going on. There you go. Yep. There she goes. All right. It's not super interesting, so let's get back to this wiring stuff. There's a mod to lower the voltage on the Viper for the stepper motor. They actually have potentiometers for each stepper motor on the Mobo, but don't have replaceable steppers. Huh, that's really weird. Those are some sexy steppers? Well, the stepper drivers sure are. The steppers themselves, these are just basic Creality extruder stepper motors. So I had to plunder several printers to source all of these. I just said holy cow. Oh, okay. Holy cow. Whoa, right, so I think we're ready to keep going here. A dummy battery with an AC adapter is your camera's future then? Oh, yeah. Well, my first camera, the camera that I started this channel with, was a Canon M50, which is a great little camera, except there's one issue with it, and that's that my dummy battery, when I pulled it out, like it came unplugged accidentally, it completely bricked the camera, so it wouldn't even turn on, which is a huge disappointment. So ever since then, I've just been more interested in getting Sony hardware and equipment, because if they can't get something basic like that right, where like if the camera comes unplugged, it just destroys itself, then I don't really want to participate in that ecosystem. It seems like Sony's got a lot better handle on handling USB interfaces, just because they've run so many different product lines. Canon has just been a camera company for the longest time. So, like when they had to learn how to use USB-C, I think it was a little bit different than when Sony had to install USB-C onto their cameras. They probably have a whole department on USB interfaces. Anyways, let's get these steppers plugged in. So, unfortunately, I didn't get the whole kit. So I didn't get the electrical kit, which means I guess they don't provide stepper motor wires, which means I'm going to have to be plundering a couple more of my printers. Everybody press X to say respects to my Voxlab Aquila that's about to be ripped to pieces. I need that X-axis stepper motor cable. So here goes. I don't know how I'm going to get this on camera. Just push all this off to the side. Excuse everything that's going on here. Alright, so I think I just need to get all of these cables out of here. And free them from their harnesses. 1, 2, I think I need all 4 of these. 3, and 4. I'm going to use these to pull this out. It's just a little bit easier. Okay. I'll get some clippers. Alright, now I've got to liberate all of these cables. So here goes. Alright, so we got a couple cables here. This is pretty handy. Out you go. Okay, so here's our X and E cable. Now let's get this out. So I actually applied this tape. I just wanted to make sure these wires didn't rub against these sharp aluminum edges. So I threw some gaffer tape in there. It's pretty good stuff. Should be pretty abrasion resistant, but we no longer need it here. So let's pull it out. This is like necromancy. I'm pulling apart this dead printer to get some bits off of it. Well, actually it wasn't a dead printer until I started pulling it apart, so I don't know if this is ethically okay, but this is the process I'm following. We're just pulling parts out of this bad boy. If you wonder how delayed it is, smiley face. Okay. We only see the top of the webcam video, by the way. What? What are you talking about? On, you mean on Yes, like necromancy. Now I get it. Yep. I'm not sure what you mean by you only see the top of the webcam feed here. I'm right in the middle of the webcam. Woo, hello. Maybe, are you talking about the Ender 5S1 webcam feed? All right, and let's pull out this last one, which is our Z-axis. It's a pretty short cable here. I don't think it's going to come out. Yeah, it's pretty tight in there, so I'm going to have to remove this panel to get access. I'm guessing it's just one screw here, but I'm just going to take this off the desk. We got most of our stepper cables there. Just one more to go. All right. This would probably be a little bit faster if I was using the full mechanical kit, but since I'm doing the, this would probably be faster if I was doing the full electrical kit that included all of the other stuff. But as is, I've just kind of got to source all these parts as I go, which is not the most efficient process, but it'll get done eventually. All right, and here's our little extruder stepper motor. Nice and short cable here. That'll probably be used for my, this is the Z-axis stepper motor, but these cable paths are so short. I mean, look at this. You're just basically plugging it in right here and then plugging it right over there. That's one of the nice things about working on a machine this small. So yeah, just really short cable paths. But yeah, so I guess since this one was a Z-axis before, I'll just keep it as a Z-axis. Because that way it's got the correct label on it, which will make my life a little bit easier. So there's our Z-axis. Boom. Next up, we've got the Y-axis. So I just separated off the little limit switch. We don't need that. Well, I don't think we need it. I'm planning on setting up sensorless homing, but we'll see how that goes. So this is the Y-axis, which should go right here. Oh, and I plugged this into the wrong one, possibly. I think it's got two plugs for the Z-axis, in case you have dual Z lead screws. But yeah, these boards are really well documented, so if I needed to find out that information, I could easily find it on Big Tree Tech's website. All right, so let's get this one plugged in here. And on the whole topic of 3D printer necromancy, I've been wondering what I should do with my old 3D printers. Like, I've just kind of had a pile of them building up. But I really like this concept of just tearing them apart and building them into something else. Because now this printer right here, I have all of the emotional attachment to my old printers that the parts came from, and I'm just compiling that into this little pet that I have now. So it's a pretty cool idea of just rebuilding your printers into other things infinitely. It's just a cool experience, cool feeling. So that's pretty good. Now let's see what else we can build. I think I have enough cable to plug in my Y-axis now, so let's get that. I don't know where the cable went. That was one of the longer cables that I got out earlier. All right, here it is. Okay, so here's our X-axis. We'll plug it in over here. Oh, I'm plugging in the wrong end of this. Here we go. X-axis. We'll plug it in over here. And then E for extruder, we'll plug that in over here. So we're using E0. There's also E1. So this is set up to have dual extruders if that's what you want to do. This main board is set up that way. And we've got a little X-axis limit switch, but we'll just pull that off since, like I said, we're probably going to be setting up sensorless homing. All right, so up top, let's plug in this X-axis stepper motor right up here. And then we've got our extruder stepper motor that'll come out the end, and we'll find a place to plug this in. And I've got these nice Velcro zip ties. These are pretty handy because you can just pull them apart and redo them if you ever need to do that. It's pretty handy when you're assembling a printer to just have removable zip ties. Otherwise you end up just using up zip ties that you're planning on cutting off later. So this is a nice little recyclable zip tie. Pretty handy. They're a little bit more annoying to use. Oh man, these are really annoying to use. I'm not sure if this recyclable thing is for me. Okay, yeah. This is not the most fun experience. Good old plastic disposable zip ties are just a lot nicer, but I'll give it a shot. Let's just wrap these up. Let's not be wasteful here. Okay. And then I'll kind of clip that on over here. Okay. All right, that's looking pretty good. There's our little cable harness. We got our extruder stepper motor, which will be attached over here, which can slide back and forth as needed. That'll be plugging into our Bondtech LGX light. Oh geez, our Bondtech LGX light has its own little cable here. So I guess we won't need this. I'll just pull that out. Kind of like how we have DNA from billions of years ago. Kind of. I think the better analogy would be like if you basically cut off your parents' limbs and then attach them to your body. I don't think that happens all that often, but you know how medical surgery goes these days. They can transplant just about anything. So if you're crazy enough to do it, okay, so it turns out I don't need this extruder cable here. We'll just pull that off. And maybe use that for another part of the build. It's always handy to have extra little cables like this. And now our Bondtech LGX is going to have its own little cable going down. That's all good. Next we can take care of the, let's see, what do you call it? This bed cable, the thermistor and heating cable for this thing. So I just gotta loosen this up and pull it out and plug it into the main board. And I'll have to make a couple decisions about how to wire this up. Okay, so that goes out the back. And I don't know how I'm supposed to run these cables. Looks like I'm supposed to run some zip ties through there. So yeah, I mean that's where we're at. I don't think this mechanical kit comes with any of the zip ties either. That's probably bundled into your electrical kit. So if you were too cheap to buy the full kit from Ratrig, then you're going to have to be sourcing all sorts of random little parts. At this point, it's really looking like a more complete kit would be worth buying. Alright, so... I'm just rerouting these cables. I'm going to check my camera battery too. See how long it'll be till I can pop you back over into 4K. Alright, we're at about 40%. I think that'll last for the duration of the stream. So we're going to get our nice camera back. This camera will record about an hour of footage in 4K with 40% battery, if that makes any sense. Maybe 40 minutes to an hour on 40%. When the battery's full, it can do like an hour and a half to 2 hours in 4K. And that's what I use for filming most of my videos. But in this case, we have it trickle charging off of the laptop, so it can go for about 3 hours while trickle charging. So, and if it was fully charged, it'd probably be able to stream for like 6 to 8 hours, which is more than anyone in the audience would want, right? So let's get this plugged in again. We'll get some better camera angles. And that delicious bokeh, that out of focus background that everybody craves. Alright, let's go back into OBS and change our audio back over to the camera. All right, so I just switched the audio over to my my shotgun mic on top of the camera. I don't know if it's better or worse. This would be a good time to do some A/B testing, so you guys can let me know which one you like more. And I'm going to switch my video back to the camera as well. All right, let's catch up with the chat and see what's going on here. Herzelnerk, we only see the top of the webcam video. Yeah, I'm curious. Oh, when I show the Ender 5S1, it only shows the top. Okay, that's good to know. Yes, like necromancy. Now I get it. Right. Okay. The Aquila lives on. Yeah, I really did like that Aquila, and I did like my my artillery Hornet printer. I put some pretty sweet mods on there, like this Fadus hot end. This was a really early sample that Fadus sent me, so it was cool to be part of that product launch. And they sent me this just to try out, and I thought it was really good. So yeah, I get to keep using this thing. It's a pretty nice hot end, all things said. So yeah, just kind of combining everything into this one machine. Frankenprinter, we'll call it that. Yeah, that's a good name for it. I like the look of the printer with the white plastic parts and the exposed board. Very nice. Well, the board won't be exposed when I'm done with it, but that'd just be a bad idea. Like if I drop anything on there, it's going to short out. But yeah, there might be a way to have some exposed PCBs on this in the end. Dual extruders on that little thing would be hilarious. Yeah, I'm thinking, oh yeah, two heads on this. That would be pretty cool. I'm also thinking multi-material unit on here. That'd just be hilarious. Like one of the smallest multi-material printers on YouTube. The only option on Ratrig is the full kit. I have heard that couplers was a bad thing due to backlash from the rubber. I don't think it'll be that big of an issue. I'm pretty sure these couplers are designed to have an interference fit, so I don't think there's slop in there, but I could be wrong. The rubber will add a small amount of springiness, but virtually everything acts like a spring at the right force and distance scale. It is bokeh, not bokeh. That should never answer the question if I'm into photography. That earlier question should answer the question. Yep, I know it. We need more Ender 2 Pro, please. Yeah, I have my Ender 2 Pro. It's I don't like to call it an Ender 2 Pro. It's an Ender 2 S1, man. It's got a Sprite hot end. If they did make an Ender 2 S1, that's exactly what it would be. Just an Ender 2 Pro, but with a Sprite hot end. Maybe some other stuff. Someone posted a pretty funny picture on Discord of an Ender 2 with, I'm trying to remember what it was. I think it had a second like gantry axis on it, so it was basically an Ender 3, but it was Ender 2 sized. Pretty funny stuff. Okay, so let's get back to the wiring. Now the wiring isn't super specific on how I'm supposed to set this up, so yeah, that's going to make this a little bit more challenging than I would like it to be, but that's just the way it goes. And also, tidying all of these cables up is going to be difficult. I've got some really nice cable wraps. It's the same stuff that they use on the Prusa machines, so it's going to look pretty good when I'm done with it. These cables are super ridiculously long. I'm not sure they need to be that long, but it's alright. So I'm just going to plug in this thermistor. That's pretty easy to do. Don't need to be super smart to plug that one in. Alright, so the thermistor goes TB is the thermistor for the bed. So we'll plug that in. I'll flip this around. No. Let's get you a better view here. There we go. So this goes to TB, which is thermistor for the bed. Right here. All right. I might as well just plug in this LGX motor. And plug it in down here on extruder 0. And then on our hot end we have these two power cables coming off of it. Those will get plugged into this little terminal block, removable terminal block, which makes it a little bit nicer to work with. So let me undo these screws and pop that in. And polarity doesn't matter here, as far as I know, so we'll just put these in and I'm gonna cut this one a little bit short. Oh my goodness. Holy cow. Okay. That was a little dramatic there. I shoved this in and it just like sunk into the little Little piece of plastic there. Okay, so I'm going to cut these a little short. And then we'll put them in these terminal blocks. All right, and we'll get our little screwdriver to fasten these down. That screwdriver's too big. Oh man, this is these are really tight. Not sure what the deal is here. I think I need to loosen these up first. Yeah, gotta loosen them up first. And then put our cables in. Oh man, they really wrenched those down. I guess they didn't want them rattling around in shipping. So I'll just put this one in first. All right, so that's all done. Somehow I got this tangled up a little bit, so I'm unplugging it and then plugging it back in. All right, and then this cable gets plugged in right back over here. Hopefully I did this right. Man, every step takes so long that when you do it the wrong way and you have to... Oh geez, I did it wrong. Okay. I'll just unscrew that. Pretend that didn't happen. That one was supposed to be for the... this little removable piece is supposed to be for the hot end heater. And plugging that in was just dumb, so just wasted some time there. I've actually got to plug it in to these little cables here. So, the far one. Okay. So these ones I also have to unscrew, then insert the cable, then tighten them. All right. There we go. there is our bed cable. I'll sort it out. Next up, I think, is the power cable. So let's see if I can scavenge that for my Voxelab as well. I think I'll be able to pull that off of the Voxelab. Oh my. Let me just get this cable off of the Voxelab here. This should just take a moment. There we go. I blew up my V-Minion's first SKR2 by carelessly shorting the part fan wires. Blew the MOSFET, had to do the worse than blowing, hard to do worse than blowing the board. Yeah, why would anyone use Marlin on this? It's a very good question. You'd have to be clinically insane to put Marlin on a machine this capable. So, good old Voxelab and the tinned wires going into the power connection. This also had the original firmware on there. The board still works, so it should still operate. But it's got the original firmware on there that someone else pointed out that it did not have thermal runaway protection enabled. So this is one of those vintage flammable 3D printers, if anyone wants it. Okay, I've got a couple more screws holding this on. I think I zoomed out a little bit for you. Yeah, I knew King Sidorak would chime in saying he wants one. Of course he would. What kind of parts would you want off of this machine? Just out of curiosity. Let me know and I might be able to ship some stuff out to you. Screws. Allen wrenches. I want it for parts. Let's see what parts King Sidorak wants. If it can fit in a small box, I might be able to ship it to you. Send him the wheels and belts. All right. Yeah, I can do that. Everything you don't need, I can pay for shipping. Do you want the heated bed? Power supplies? I guess it's actually got a pretty nice extruder on here. It's got a what do you call it? Micro Swiss direct drive extruder. Pretty nice setup. The screws sticking out scratched me. I have one of these that I put a Sprite on. All right. Okay, here we go. We've almost got this thing apart. And there we go. This is a Meanwell power supply too. Holy cow, these old Voxlab Aquilas actually came with some pretty nice hardware. Someone was telling me, I'm not sure what kind of stepper motors were on here, but I'll take a look at them in a minute. I just gotta get this little cable off of here. So this is a 16 gauge wire. I think that should be enough for the power needs of this machine, unless I end up getting some crazy stepper drivers on there. And I will just, I think I should put some crimped ferrules on here, just to practice what I preach. And we just happen to have some handy. So I will use, oh yeah, by the way, I dropped these on the floor. You never want to drop a box like this on the floor because it's just going to become completely disorganized. But I think I'm going to use 2 of these little red ones. I'm hoping those are the right size. And then trim off this tinned end. Strip back some wire. And put on some new crimped ferrules. Alright, and this these red crimps are a little bit too small, so I'm going to move up in size. We're going to go with, well, let's see, this says 16 AWG. It says the black ones in this kit are 16 AWG, so I'll just do that. In case you were wondering, this is exactly what it's like when I'm putting together all of these printers for reviews. The only exception is I do a lot more takes when I'm filming for a review video, and I swear a lot more. But overall, I don't think you guys are really slowing me down that much. Alright, so let's put these little crimpy boys on. And that's good, so let's put both of these on and get them crimped. So we'll crimp those and then trim off the excess. Alright, now we've got some nice solid metal plugs to plug in here. And for this one, the polarity does matter. So I'm going to go red towards the front and black towards the back. It almost rhymes. So just like before, I got to loosen these up first. And then I'll do the same for the other pin. the key to making progress in a build like this is to just keep going. Like, there's only a certain amount of things that you need to do before the build is complete. You just gotta keep doing things one after another until it's finally put together. So it's kind of a endurance and willpower test to see if you can actually do it. Okay, so this is pretty short here, this cable. So I'm gonna have to find a place to mount our power supply that's pretty close to the back of the machine. It looks like I might be able to mount the power supply right here vertically. I'll have to 3D print my own mount, but this looks like a pretty sweet spot for it. Let's see, where is our power supply? I guess that one's plugged in. There it is. So I'm thinking of using this Meanwell power supply, just mounting it like right here. And then as this moves up and down, I mean, that's kind of out of the way. It kind of makes this machine look a little bit bulkier than it needs to. I guess I could also mount it up. No, I can't mount it up front because that's where the spool goes. I think this is going to be it, right here. What do you think? Asking for second opinions here. So if this is all put together, I mean, these wires are ugly right now, but just try and ignore that mess because that's going to get all tucked away in that box. But it would look kind of like this. I don't know. Personally, I like it. And it also will kind of act as a backstop for if I'm shoving this up against the wall. This will be kind of the rearmost point by just about a centimeter so that I don't accidentally put it too far back so the bed runs into the wall. I mean, that's what I'm thinking right now. But that'll require me to 3D print something out. And in the meantime, it's probably just going to lay flat against, like right on the side here. I could put it under the machine over here, but that's not going to look very good either. Yeah. Right here, looks like it'll do the trick just fine. Maybe sideways like this. Feel free to tell me I'm ruining it. But yeah, I think that's what I'm going to be going with. Alright, so we're a little over 2 hours into the stream. That means our Ender 5S1 print job must be wrapping up. So I'm going to check on the chat, see how it's all going. In the meantime, I'm going to give you a sweet view of that that print job. Oh, wrong one. Hold on a second. That's not what we want. Okay. This one. Alright, so looks like it's just looking at the top here. Oh, it's confusing when your mouse is on the screen. But let's see. Alright, so I need a better system for this. That's for sure. Okay. Oh, the print's done. There you have it. So I'm going to run down there and pop that print off. And we'll see how it turned out. Looks like our overhangs look pretty good. But time to do a print quality assessment. I'll be right back. All right, and we're back. So here's our print. It's looking pretty nice. Looks like these overhangs turned out really good. Pretty sweet print overall. Alright, so this is where we're going to attach our extruder. And then this is where we're going to attach... No, wait. This is where we attach the hot end. This is where we attach the extruder. So, did I mess up the stream or something? Because it's looking like... oh, yeah. So I needed to shrink this down or something. So you can see the full screen. Not sure exactly how this is supposed to work. Crap. Uh-oh. Uh-oh. No. Let's get this back to normal. Okay. There we go. Alright. So... And this is like one of my first kind of experiences streaming, so pardon the technical difficulties I'm having, but I'll learn this stuff as we go, and eventually everybody's going to be watching my stream. We're going to have 1 million subscribers, 100,000 viewers on every stream. It's going to be amazing. This is the future that we're building together. So send me those parts. I'm near Chi-Town. Where's Chi-Town? Chicago? Alright. Streamlabs OBS is really nice to use. Yeah, I agree. It's really not bad. I just need to get a little more experience with it and get some presets set up so I can just click between things a little more easily. I think there was a mismatch between the screen capture resolution and the streaming resolution, and that's why you were only seeing the top corner of what was going on there. But, yeah, okay, Chi-Town, yeah. Chicago. I should be visiting Chicago soon. Oh, alright, where'd you move from? I haven't been to Chicago at all except for the airport. But, you know, there's always opportunities to go see new places. Streamlabs bad. I kind of like OBS. Like, I've used OBS for a while just for doing screen captures for YouTube videos, and it's super easy to use. So, I mean, there's nothing wrong with the tool that I'm using already, so I'm just gonna stick with it. Oh, okay. Namion, you use OBS as well? What do you stream? What do you stream, Namion? If you don't mind sharing. Oh, okay. Namion is using Streamlabs. From what basic stuff I know, Streamlabs basically is built on top of OBS. So, you know, they're kind of commercializing some open source software. Nothing wrong with that, but at the same time, they better be offering something that's a better user experience than the open source software, because that's going to be your cheapest route pretty much always. Like, OBS is free to use. NC, yeah, I've visited in North Carolina before. It's a nice place. Lots of swamps and stuff, if you like water. Okay, so I'm going to attach the I'm going to attach this here extruder to this plate, following a couple instructions. And then I'm going to attach the Fadus hot end to this thing. So let's get that done. Yeah, to what King Sidorak is talking about, Streamlabs versus OBS, I heard there was some drama between them. King Sidorak is up to date on all of the streaming drama. Alright, nice. Some off-the-wall games. Sounds fun. Yeah, one game that I keep coming back to is Rust. That game is just ridiculous. It really kind of shows you how many psychopaths are out there on the internet. Like little kids that'll just lie to you and like gain your trust and try to break in and steal all your stuff. Little crazy kids out there. But it's not personal. They're just doing what they want to do. Oh no, Namion is hating on the version of Clipper that's on the Sonic pad. Alright, so I gotta figure out how to line this up. I think I just need to look at some instructions on the EVA. Oh crap, I think these parts that I just printed are for the EVA 3.0 or like the latest version of the EVA, and the old version of the EVA is the 2.4.2. So I might run into some compatibility issues here. Hopefully I don't, but that's a real possibility. I'm hoping it's backwards compatible. We'll find out soon enough. If anyone knows, though, if you let me know, that'd be great. It looks like... these hole patterns aren't really lining up all that well. So I'm guessing this kind of sticks off to the front a little bit. So anyone know about this EVA compatibility stuff? think I'm going to have to do some research on this so I can finish up this build. EVA is a carriage platform for MGN-based rail printers. I think I'm going to use the old version of the EVA, which means I might have to print out another part. But I'm going to take a look at a couple of things and see if I can get this going. I did print out what should have been the Rapido version. So I'll just check that out shortly here. Face Rapido, open with Prusa Slicer. Okay, so there's yet another version of this that I might need to print out. So if that's the case, I might have to end the stream and pick it up later. But we've made some good progress today. We got this this little thing installed back here. We got a lot of our wires plugged in. We've still got a ways to go though. This is not a quick and easy build. I'm going to check in on the chat, see what's going on, if anyone's got some advice on this EVA issue. Did you try Kerbal Space Program? Yeah, Kerbal Space Program's fun. I haven't tried Kerbal Space Program 2, the new version. I heard that Rust is really fun, but I never tried it. The videos of guys setting up the trap shops is hilarious. Yeah, it's pretty fun. Get the drill? Yeah, I could just... I mean... Whew, at this point, I'm just tempted to take this whole top rail off and throw a sprite on here. I mean, say what you will about the sprite, but it's easy to set up. Like, it's just... You just slap it on there and start going. And I could use a modder board and everything. You know, get that advertisement or whatever you want to call it going. Some product placement. The funny thing is I have all the parts. I could throw a sprite on here in about 10 minutes. So it's really tempting. But shoot. Let's see. Not hitting on it. Just easy to outgrow for someone that likes options. It's easy for someone that is just starting out or wants to plug it in and it works though. Yeah. So that's definitely the case with the Sprite hot end. It's just plug it in and it goes, but it's a little more difficult to tinker with. Hey Rohan, thanks for checking in. Yeah, the build's coming along. I've got a lot of the wires plugged in now. I'm about halfway through just with getting the wires plugged in. I got my belts strung on my y-axis. My x-axis still needs some work because I'm just confused by this this ecosystem that Ratrig has. There's a lot of parts to it. I think this goes on here. Yeah, I think I'm mixing parts between the newer version of the EVA and the older version. So I think I'm just going to have to go through and reprint things to make sure that I've got all this compatibility stuff sorted out. Because at this point, it's just kind of confusing me. Alright, let's see what else we got going on in the chat. How do you wire your dual fans? Well, this is set up to just have one fan for the part cooling, and then another fan for the heatsink cooling. So, stripped it down today and found while the Sonic Pad reports it uses 2 gigs of DDR4, it has 2 8GB chips on it, along with the onboard storage. Alright. That's good to know. I was surprised that the storage was a SanDisk chip. I mean, if it's got good hardware on, that's pretty nice to know. Like if you could find some way to hack it and flash it over to something more just like stock Raspberry Pi stuff, then that would be great. Don't talk about Kerbal Space Program. My space-made 5-year-old keeps asking for it on his iPad, but you can't get it. So instead, he has every similar iOS game. Yeah. I mean, Kerbal Space Program is great. It teaches you so much about orbital dynamics and aerodynamics and stuff. So some real-world useful physics that you can learn there. Yeah, I've heard Kerbal Space Program 2 is not like in super great shape right now. It's a little bit buggy. So I've just got Kerbal Space Program 1, and I don't play it enough to really purchase the next version. Do it, melt some plastic? No. I don't know what to do here. Let's see. I think I'm just going to stick with the 2.4 build. The EVA 2.4. My 5-year-old learns to build planes in KSP and starts to learn flying from them. There are KSP parts with magnets. Lets you build like in-game. Yeah, KSP is really fun. If anyone hasn't checked it out, it's a pretty cool STEM, aerodynamics, and aerospace tech game. Oh, you're worried about handing your PC over to a kid. Yep, fair enough. I can see how that might go wrong in several ways. But just load up the game, and if it crashes out, then... okay, so Rohan, EVA 3 should be pretty easy. What were you having issues with? So I printed out the included parts that come with the Ratrig build that they recommend. And then I was like, alright, I want to put this Bontech LGX on there. And there's Fadus Rapido on there. So I printed out these pieces, but it seems like it's not compatible with the rest of the parts that I've printed already that came with this, this printer kit. So I think this is the EVA 2.4, and these parts that I printed out are for the EVA 3. Oh, so EVA 3 isn't officially finished for the V-Minion. Alright. I think I'm going to just stick with the EVA 2.4, and I'll just print out the correct pieces for it. I just think I might have forgot to print those, or I lost them or something. So I'll fire up the printer. We'll get that started. So for the next stream, we'll be able to get that all assembled. Yeah, I mean, I think it's coming along nicely, though. I've got a couple more wires to run. I've got a couple more things to put together. But I think if I do one more stream, I might be able to get everything put together. And at first, my power supply is just going to be kind of hanging off the side here. Like, the power supply is going to be just like this, which is not very safe. Maybe I'll use a Dell laptop power supply. I actually have one of those, so I'll probably use that at first. And then I'll either stick with that, or I'll come up with something to hard mount this onto the machine. Or maybe an even smaller power supply, because this is 350 watts. This bed only draws 180, so I could probably get away with a 300 watt or like a 280 watt power supply. The nice thing about having a 350 watt power supply is I've got tons of overhead for running high current stepper motors. I guess they can pull about 2 amps each. So if I've got 2 stepper motors running 2 amps, that's going to be 2 amps, 24 volts. That's like 100 watts of just stepper motors. So I'll probably want to get this thing running later on down the road. But for now, I'm probably going to pull up that power brick. Alright, good. Thanks, John. Go get some groceries. Make sure to get some healthy food while you're out there. The only issue seems to be the X stop switch not hitting in the right place. Well, that's not too big of an issue for me because I plan on doing sensorless homing. So hopefully that wouldn't be an issue even if I installed the EVA3. Print a case for it and you got a DIY Dell power supply and throw it out on top of the floor. Throw it on the floor, yep. Okay. Yeah, I could do that. Okay, so let's make a game plan here. I'm going to download and start printing the correct version of that EVA. So the 2.4. So EVA 2.4, we'll get the Rapido face and the LGX Lite drive. Now, would you recommend the LGX Lite or the normal LGX? Because I have both of them, but I'm thinking the normal LGX is going to be just fine. I mean, the LGX Lite is going to be just fine because basically hold on, I'm just downloading all these parts and I'm going to start up a big print job. Rapido. Because basically I don't plan on doing extremely high flow rate printing with this machine, so I'm not sure what the advantage of using the large LGX would be. Plus that extra mass might kind of slow down my x-axis a little bit. And I want to go fast with this thing. And this has got a really small light stepper motor, so that should be able to go pretty fast. I'm going to share my screen so you can watch me do all these slicing things. I know slicing is just the best part of 3D printing. Unironically, it is probably one of the most fun parts of 3D printing. Shoot. Alright, I think I've figured out how to do this. Here we go. Welcome to the infinite space of stuff here. Alright, so here's your nice view onto my desktop. I think I'm going to print these out on the Bamboo Lab. I had plenty of prints running on my Ender 5S1. I think it's time for the Bamboo Lab to do some work. So we'll fire up Bamboo Studio and import all of those pieces. So downloads. List, and we'll sort by date, and we'll just grab all of these files I just downloaded. Alright, and if you haven't seen Bamboo Slicer, it's actually pretty awesome. You have your options for auto-organizing, but if you have a ton of parts, it'll have additional plates. So like you can take a couple of pieces and put them on this different plate. And this gives you a really simple interface for being able to print out, start up multiple print jobs on multiple printers. Let's say you've got a job you need to finish in like half an hour. You could load up each one of these onto a different plate and split this job up into like 4 different printers, like this. So you can just kind of split this up, super easy, and then auto arrange all. Oh, it consolidated it down into one sheet here, but I would just auto arrange each one of these separately. It's pretty fun. And I like how they put little buttons for the individual plates on the actual user interface in the 3D graphical interface. That's pretty cool. And then you can like lock this one if you want to auto arrange. This one's locked, so now if I auto arrange, it should consolidate everything onto one plate and leave this one alone. So it's just pretty cool. But I've just got one printer from Bamboo Lab set up to print right now. So I'm just going to arrange these all onto one plate. Looks like let's see. These parts look different than the ones that I printed. But maybe they're not. No, these are all relatively similar to what I've got already. So I've already got this part. I can delete that. This looks like a new piece. Looks like they've changed their design here for the back plate. You know what, I'm just going to print everything out just because I just want everything to work, so I don't really want to mess around with this too much. I don't know if the orientation is correct on these the way that it is, but everything looks pretty good. This all looks relatively printable. So I think I'm just going to go with it. The only one that looks a little iffy is this one right here. I'm thinking it makes a little more sense to lay it down on that face. That's Bamboo Lab's automatic orientation, which looks pretty good. That should print just fine. Yep, all of these look pretty good. So we'll just go ahead and print this out on the Bamboo Lab machine. And I'm going to turn the speed down. So let's go to, yeah, I guess this setting will be pretty good. So auto arrange and then slice it, and let's see how long it'll take. Alright, so this will take 5 hours, and it all looks pretty good. The only part that it automatically assigned a brim is this one. And I guess that'll be fine. So yeah, this design looked like it's changed a little bit since they released the version that I have printed out. So I'm just going to go ahead and print this. And then I guess on my Ender 5, I'm going to slice up some other stuff. So let's get the let's get some parts printing here. V-Minion main to CAD printed parts, machine STL. So I need to print out the top piece. This one's Z cap, and I need to print out a second little end cap for the spool holder. Let's just find that in this list. I think it's this one. Okay, so that one and the Z cap. Let's open those, and we'll slice those up. Oops. Oops. No. There we go. And we'll slice those. So we'll have both of our printers running. The Ender 5S1 will print out this big piece and this little piece, and our Bamboo Lab will print out all of these pieces for the hot end. So I'll get that started in a little bit. I'll probably run that in the morning, just because I don't want to run my printers overnight. That's generally not a good idea. Let's see what's going on with the chat. Alright, John Stern's probably long gone to the grocery store at this point. Run my Y motor at 1.8 amps. All right. Print a case for it, and you got a Dell power. Yep. Wash your hands. Yeah, sorry they're a little greasy. This is just what happens when you work with these filthy bolts, these filthy nuts and bolts. So I'm definitely going to wash my hands when I get done with this. Maybe get some shock-resistant PLA you could test out. I wouldn't put electronics, especially power electronics, in a PLA enclosure just because PLA has such a low melting point. Oh yeah, JK, alright. You redeemed yourself there. Light sounds better, yeah. LGX Lite seems like it's probably a better fit for this machine. So I'll stick with the LGX Lite there. Oh yeah, you guys can see my screen. Well, welcome. Here's my screen. Quad core printing, yeah. Actually, cool feature. Now I just need that. I may need that printer. Well, actually, there's like the Soft Fever fork of Bamboo Slicer. So if you want to use it without using a Bamboo run slicer, then you can always do that. Oh, you know what's interesting is Bamboo Lab has a third-party application built into their slicer. There's some drama about this in the open source community, saying like, oh, well, they're taking an open source product and then basically they're making a privatized fork of it, and they're keeping all of this stuff private and on the Bamboo Lab cloud functionality. So one issue with that is they're basically providing a DLL or a library of all the Bamboo cloud functionalities and lumping it into their own little library that's private that you download and reference as part of the open source compilation of the Bamboo Studio app. So basically, we don't know what's going on in Bamboo Studio in terms of what they're reporting back to the cloud, which just gets back to that whole thing about data privacy and security. What are they sending back? Well, you can't really look at the code as to see what exactly they're sending. You might be able to get some higher level views of what kind of data gets sent, but with the bulk of the code being contained in the private DLL, that's not being released, and it's kind of going against the spirit of having these open source projects. You know, you're taking it and making it a closed source project in some areas. So, you know, that's just some stuff that's going on. It's kind of interesting. So if you can do the Soft Fever fork or, you know, completely disable that cloud functionality altogether, I would go for it. Because who knows, it's possible. I don't really know enough to really speak with any authority on this, but it's possible that every time I slice this, it sends that information to Bamboo about all my STLs and my settings and my preferences and stuff, which is just, that's just interesting. That was a quick slice. Those M1 chips are pretty quick. Yeah, everything slices fast in my Bamboo Lab and in my Prusa Slicer. I mean, Bamboo Studio is built on Prusa Slicer, and my Prusa Slicer just slices things basically instantly. Like, oops, if I move this, then I can get it to reslice. So, boom, it's done, like in a second or less. Versus Cura, I often have to wait 20 minutes for a slicing job to get done. Those are some extreme examples, but it's pretty normal to have to wait about 5 to 10 seconds for a job to get sliced in Cura. 25-second stream delay, by the way. All right, good to know. There's Orca. Oh, Orca, okay. I don't know much about that one. It'd be nice if they add more printers for the slicer, yeah. All right, well, I'm gonna fire up these 2 print jobs probably tomorrow morning, but I think I've gotten about as far as I can without being able to put that x-axis together. So if you tune back in to the next exciting episode of Nathan Builds Ratrig V-Minion, then you'll get to see the conclusion of this build. I'm feeling pretty good about this. I think I'll be done with it in maybe another 5 or 6 hours of building. So it might be 1 or possibly 2 streams before it's done. Alright, well, with that, thanks for watching, everyone. I'm a Prusa sock puppet shill. I'm sorry. Well, anyways, thanks for tuning in, everyone. This is the 3rd episode in the V-Minion build. I got a little bit further today, so I think 1 or 2 more streams will have this thing done. And thanks for joining and participating and chatting and everything. And if you want to keep the chat going, head over to the Discord. I might pop in there, but I got some chores to do around the house, so I'm not going to promise anything in terms of my attendance in the Discord. So, as always, thanks for watching, everyone, and I will see you in the next episode. And how do I get off of this stream? Oh no, I'm stuck here. Let me leave. Let me leave. Ah. No.